Hello and a bright and early good morning from Rocket Lab's Mission Control Center. We are bringing you a live view of Electron on Pad B at Rocket Lab Launch Complex 1 in Mahia, New Zealand. I'm Felicity Powell and I'm so glad you're joining us for the launch of Rocket Lab's 31st Electron launch, a mission we've called It Argos Up From Here. The mission is a dedicated launch for our customer General Atomics Electromagnetic Systems Group, supporting the US National Oceanic and Atmospheric Administration and the French National Center for Space Studies. Right now, we are 17 minutes away from target liftoff at 0609 local time, or 1709 UTC. Today, we have an instantaneous opportunity for launch, but if we need to stand down for any reason, we do have backup opportunities available in the coming days. Today's launch will be our 8th for the year. This sets a new record as our busiest launch year yet, surpassing our previous annual record of 7 missions. Since April this year, we've also successfully maintained a monthly launch cadence, which we're on track to maintain for the rest of the year. Very exciting stuff. Scheduled for liftoff today, though, is a dedicated launch for General Atomics. Electron will launch the Gazelle satellite carrying Argos 4 advanced data collection system to the Argos constellation on behalf of the US National Oceanic and Atmospheric Administration, also known as NOAA, as well as France's National Center for Space Studies. This mission supports an international program that collects data from about 13,000 transmitters operating around the globe, serving a host of applications including tracking of buoys, fishing vessels and wildlife, collection of environmental data such as ocean temperature profiles, river levels, and even animal heart rates, and observation of ocean parameters such as currents, temperature, and color. Let's hear more about General Atomics and its payload.
Welcome to the launch of the General Atomics Gazelle spacecraft to low Earth orbit. I'm Greg Burgess, Vice President of GAEMS's Space Systems Division. The Gazelle spacecraft is hosting 2 payloads, the NOAA-provided Argos 4 animal tracking payload and the RADMON radiation monitoring system. We are proud to join our partners at NOAA, CNES, the U.S. Space Force, KSAT, and Rocket Lab to launch this critical capability to capture, process, and distribute environmental data globally. The Gazelle spacecraft is the first satellite that General Atomics has built as part of our science and weather program. It's based on the same platform we used for the Orbital Testbed 1 satellite we launched in 2019, as well as the base platform for our NASA Thesis 2 spacecraft scheduled for launch in 2024. Lofting the Argos 4 payload will significantly increase the speed and reach of the Argos constellation, joining its sisters in space to collect global animal movement and migration data.
With this launch, the Argos system will be improved and extended, which will benefit all current and future users around the world. There are several thousand individual users or programs using Argos to track more than 13,000 objects today, primarily for wildlife tracking, such as seals, turtles, dolphins, and many more. This also includes ocean applications, including weather stations in very remote locations such as Antarctica and Greenland, among many others. The US is the largest Argos user of 100+ countries that have Argos applications. NOAA Fisheries is the largest US user with more than 30 individual programs for seals, turtles, and many other aquatic species in the Atlantic, Pacific, Gulf of Mexico, Arctic, and Antarctic. NOAA is honored to have been a partner with CNES for the provision of the Argos system since the late 1970s and thrilled Argos 4 will take us to 50 years of cooperation.
For this program, General Atomics is providing a true end-to-end commercial space capability by designing and building the satellite, hosting a payload for our customer, performing all integration and testing, and operating the space system once it's on orbit. We've procured the launch service from Rocket Lab, and we also contracted with KSAT to provide a commercial path for rapidly getting the data to researchers worldwide. We know that our work today will deliver an enduring legacy for many years to come. Understanding the movement and habits of animals helps us better understand the amazing species that we share the planet with, and will help humanity learn how to be better stewards of all life on Earth.
In addition to launching the satellite on Electron, our team in New Mexico supplied the solar panels that will power the spacecraft once in orbit using the very high-efficiency IMM Alpha solar cells, a best-in-class efficiency solar cell that is more than 40% lighter than typical space-grade solar cells. It is now 0556 here at Mission Control, and we're approaching T-minus 12 minutes in the count. Soon, our operators will run through the go, no-go poll led by Launch Director Michael Pearson. Let's throw it over to Mission Control and check in on how we're tracking for launch.
All stations LD on mission, proceeding with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is going.
GNC.
GNC is go.
VCon.
VCon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Met is go.
MM.
MM is go.
And LD SUP.
LD suffix go.
A go, no-go sequence complete. We are T-minus 11 minutes and 15 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
And just like that, confirmation from Mission Control that all systems are healthy and we'll be proceeding with the remainder of the count. The T0 liftoff time remains 0609 New Zealand local time, or 1709 UTC in approximately 10 minutes' time. Today's mission is our 31st Electron launch, but soon enough, another rocket will take to the skies bearing a Rocket Lab logo. That's right, I'm talking about the Neutron rocket, which will be launching from Wallops Island in Virginia. Recently, we announced a major step in the Neutron development program, selecting NASA's historic Stennis Space Center in Mississippi as the test complex for Neutron's Archimedes engine. Let's take a closer look at that facility now.
Since its formation in 1961, NASA's Stennis Space Center in Mississippi has operated as America's premier propulsion test site and has tested the engines for the Apollo, Space Shuttle, and Space Launch Systems programs. Now, it's also going to be the home of Rocket Lab's Archimedes engine test program, playing a vital role in the development of our Neutron rocket. The Archimedes Test Complex will be located within the larger A Test Complex at Stennis and will include exclusive use of land within a 1 million square foot area for 10 years. The complex will include exclusive use and development of existing industrial NASA infrastructure and the center's A3 test stand to develop and test Neutron's Archimedes reusable engines. By expanding Stennis Space Center to include the Archimedes Test Complex, we plan to bring new, high-tech jobs to the state of Mississippi. At the same time, construction continues at the Neutron Production Complex and launch site at Wallops Island, located within NASA Wallops Flight Facility and Mid-Atlantic Regional Spaceport on Virginia's eastern shore. Combined, the two sites represent over 2 million square feet of operations for Neutron's production, testing, and launch facilities.
This is such an exciting time for Rocket Lab, and we are moving full steam ahead on developing Neutron, which will further open access to space to improve life on Earth.
Stage LD mission.
LD stage.
And proceed with sequence 57, stage terminal checks.
Copy, proceeding with sequence 57.
Stage 1 and Stage 2 high voltage batteries ready for flight.
GC, LD mission.
LDGC.
Proceed with sequence 58, launch pad ready.
Roger, proceeding with launch pad ready.
It's now approximately 7 minutes before liftoff, and while today's mission is lifting off from Launch Complex 1, our teams in Virginia are gearing up for our very first launch from US soil in December. Electron has arrived at Launch Complex 2 and is undergoing final integration checks ahead of payload integration and launch. Before we get to launch, though, our team will perform what is known as a wet dress rehearsal, a critical test that we conduct for each and every mission. A wet dress rehearsal is essentially a practice launch day, where the rocket is rolled out to the pad, and we undertake all the same steps that we would on a real launch day, including filling Electron with liquid oxygen and kerosene, hence the name wet dress rehearsal. With the development and production of launch capabilities on Virginia soil, we've got plenty of roles to fill. From developing our new large launch vehicle Neutron to building satellites and their components for constellations and interplanetary missions, there's something for people from all areas of expertise. Over the last year, Rocket Lab has expanded to even more locations across the United States, which means more opportunities to join Rocket Lab no matter where you call home. We'll soon be updating our website with more information about the internship programs available at each of our 9 Rocket Lab global sites. And of course, we are constantly seeking new talent and inspired aerospace professionals to join us in our mission to go to space to improve life on Earth. Let's hear from some of the team about what life is like working at Rocket Lab.
10, 9, 8, 7, 6, 5, 4,
Engine
3,
starter.
2, 1.
Lift off, vehicles get the pad.
Yeah, for me, I just really love the mission of the company. I think as you look at what we do and the challenges we take on, we don't do easy things, so we look for people that are motivated by that. Joining a company that's not just a job, it is part of the mission of what we're doing and trying to make life better on Earth via doing incredible things in outer space.
The reason I joined, I was in a rocket club in college. With a lot of the rocket building in general, it's all kind of scrappy. Let's make it work. And so you just have all this passion behind it. And so I really just wanted to be part of the industry.
I was excited when I got a position for here. I'm like, oh, now I get to go above in space and see how the great beyond is.
I know it's kind of daunting. Manufacturing doesn't look all that glamorous, but it really is very, very exciting to take a product and physically work on it yourself and manufacture it, make it work, and then fly it.
Archimedes being the next engine that we're building for Neutron, which is the next rocket, which is going to be integrated and built in Virginia, along with a bunch of other deep space stuff. We're going to Venus, we're going to Mars. It's just it's endless possibilities.
Oh man, every launch feels like you just won the Super Bowl, honestly. It's a ton of effort. It's usually dozens of people putting their effort in over time. And so when you finally see that launch,
it's awesome. Yeah, you could hear a pin drop in the room as we're all watching the launch, right? And everybody's tuned in, and we know exactly which parts on every launch.
Neutron is going to be probably one of the most innovative rockets in the world, right? It's unique designs from the structure all the way down to the engines. But beyond that, in Virginia, we're starting from scratch, right? You have the opportunity to really develop something and have a major impact on not only the design of the product, but also the design of the building, the facilities, the process, and the launch complex itself, which to me is an incredible opportunity. I would love to do something like that.
Lift off, vehicles get the pad.
To find out about our internships and open roles, check out the careers section of our website. As we approach T-minus 3 minutes in the count, we're approaching Electron's auto-sequence start, which engages at T-minus 2 minutes. As day is about to break on Launch Complex 1, the team in range control are tracking no issues with the range, the weather remains clear, and all surrounding areas are within safety parameters. With LOX loading near completion, Electron is almost ready to head to space. Let's hand things over to the team in Mission Control and listen in to the last few minutes. I'll be back with you shortly.
All stations LD on mission. From now on, there should be no red flags in your critical LCCs. VCON LD mission.
LD VCON.
Confirm all expected flight computer ASGOs are green.
Confirmed ASGOs are green.
Lock auto sequence and confirm.
Confirmed auto sequence is locked.
Okay, all stations, we are go for auto sequence start at T-2 minutes. LD is go for launch. LD Shadow, confirm go for launch.
Confirm go for launch.
Vehicles on internal power. AFTS is green and enabled for flight.
Locks load complete. Lock system in research. All helium anti-gas ring disabled.
Stage 1, Stage 2, press for flight.
High flow engine purge enabled. Deluge activated.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3,
Ignition.
2, 1. Liftoff.
Stage 1 proportional, no nominal.
T plus 38 seconds and our 31st Electron has lifted off from the pad at Rocket Lab Launch Complex 1. Electron is powering its way to orbit for General Atomics. The next milestone after liftoff is max Q, or maximum aerodynamic pressure. This is the moment during launch when the forces on Electron are at their peak, causing the most amount of stress on the rocket. Let's listen in for the call from Mission Control that Electron has cleared through max Q.
Cleared max Q.
HV battery discharge nominal.
That's confirmation from Mission Control. Electron has successfully throttled down, passed through max Q and ramped back up ahead of stage separation. We're currently traveling at over 2,000 kilometers per hour and at an altitude of over 20 kilometers. The next 3 milestones happen in relatively quick succession, within seconds of each other. First things first is MECO, or main engine cutoff. The 9 Rutherford engines will throttle down and then shut down completely before step 2 of this sequence. Separation of the first and second stages is next, and you'll see the first stage drop away from the stage 2 body. And lastly, to continue our journey to orbital insertion, we'll see ignition of the single Rutherford engine on Electron's second stage, continuing the journey to deliver the Gazelle spacecraft to its destination.
15 seconds to Miko.
Miko, confirm.
Stage separation successful.
Stage 2 ignition.
And with the nozzle extension on the Stage 2 Rutherford engine glowing, we've had successful MECO, separation, and Stage 2 ignition. Now that we've passed through the harshest part of Earth's atmosphere, we no longer need to protect the payloads, so we can eject the fairing halves to save some mass. Let's keep an eye on your screens to catch a glimpse. You might have caught a flash of it there on your screen. This fairing has successfully ejected. Stage 2 is continuing nominally with its General Atomics payload to orbit. The vehicle is currently at over 120 kilometers of altitude and reaching speeds of more than 8,500 kilometers per hour.
Guidance is nominal.
Stage 2 propulsion is nominal.
Everything is looking great at the start of our Stage 2 burn. That nozzle extension is glowing red hot as Electron powers through space at over 9,000 kilometers per hour. You'll see on the right of your screen those propellant levels depleting slowly, with about 76% of liquid oxygen and 75% of RP1 kerosene remaining. If you're just joining us, we're live for our 31st Electron mission at Argos up from here for General Atomics. After a successful liftoff at 0609 local time, we're in the first part of our Stage 2 burn. And in case you weren't aware, this week is actually World Space Week, an international celebration of the space industry and the part it plays in the future of humanity. The theme for this week is space and sustainability. This mission for General Atomics contributes to global sustainability by enabling scientists to monitor the behaviors and health of wildlife. Follow our social media channels for more World Space Week updates. Those familiar with our 3D printed engines will know that Rutherford engines use batteries to power their propellant pumps. But, much like anything that runs on batteries, that power source gets depleted, and soon a fresh battery is required to keep things going. The process of switching out this power source mid-flight is what we call the battery hot swap. You should see the battery packs falling away, that shiny silver object on the right of your screen. So let's listen in for the call out from Mission Control.
Stage 2 propulsion still nominal.
Hot swap successful.
And battery hot swap is confirmed. The Stage 2 engine is powering the General Atomics payload to its destination orbit at 750 kilometers above Earth at an inclination of 98 degrees. No, not the 90s pop group, but a Sun Synchronous Orbit, or SSO. This allows the satellite to be positioned over the same location on Earth at the same solar time every day. We're well above the Kármán line now and on our way to orbit. Just before, you might have seen the battery hot swap, where we switched out the depleted batteries from feeding the Rutherford pumps on the second stage engine with a new one. The pumps are driven by an electric motor which provides fuel and oxidizer to the combustion chamber, spinning at a rate of over 42,000 RPM. The vehicle with payload is healthy, currently traveling at speeds of over 18,000 kilometers per hour and at an altitude of over 290 kilometers. This launch marks our 31st mission and our 8th for this year, which is now our highest number of launches in a year, and we still have plenty of 2022 left. As I mentioned earlier, our first mission from LC-2 in Wallops, Virginia is slated for the end of this year, and we're all very excited to baptize our third launch pad in fire from those 9 Rutherford engines. A quick update from Mission Control for our 31st Electron mission. It goes up from here. Electron is cruising at a speed of over 22,000 kilometers per hour, and it's in an altitude of just over 300 kilometers. With just a 10% LOX remaining and 10% RP1 remaining, we're coming up on SECO or second engine cutoff ahead of kick stage separation.
Guidance on toner, 27 seconds remaining.
SECO confirm.
Nominal transfer orbit.
Stage 3 separation confirmed.
Much like main engine cutoff, the Stage 2 Rutherford has now throttled down before the stage separates from the kick stage as it continues on to payload deployment in the next 40 minutes or so. You've seen it on your screen. The Rutherford engine on Electron Stage 2 successfully throttled down, and Stage 2 and the kick stage now have separated. The kick stage will now enter what we call a coast phase. For the next 45 minutes or so, the kick stage will be in an elliptical orbit around Earth before the Curie engine ignites and raises the kick stage's perigee to put us in a circular sun-synchronous orbit we mentioned earlier in the broadcast. From here, we'll deploy General Atomics' Gazelle satellite. We won't have live video feed from kick stage of payload deployment on this mission, but we will stay with you on this webcast to bring you a simulated view of this process. While we're in this coast phase around the Earth, we'll also take a bit of a break on the webcast, but we will be back with you closer to payload deployment to listen in on those final moments from Mission Control, with payload deployment expected to take place at about T plus 55 minutes. I'll see you back here soon. Welcome back to the webcast of Rocket Lab's 31st Electron mission. It goes up from here. If you're just joining us, today's launch included a successful on-time liftoff at 0609 New Zealand local time or 1709 UTC. At T plus 2 minutes 23 seconds, we had MECO off the 9 Rutherford engines on Electron's first stage. 3 seconds later, stage 1 and 2 separated, followed by stage 2 ignition at 2 minutes 29 seconds into the mission. We experienced a successful battery hot swap, followed by SECO at T plus 9 minutes and 8 seconds, and kick stage separation a few seconds after that. The kick stage has completed its first pass in an elliptical orbit of Earth, and a few minutes before we came back to this broadcast, our Curie engine on Electron's kick stage ignited and burned for 23 seconds to position the kick stage in circular orbit, so we can deploy the General Atomic Satellite on board. Let's listen in to Mission Control for confirmation of payload deployment.
Here we go. Payload deployment confirmed.
Nominal orbit.
As you head there on Mission Control, there goes the General Atomic Satellite, Gazelle, successfully deployed by Electron on this mission. It goes up from here. That completes today's 31st Electron mission, our 8th for 2022, and officially brings the count of satellites deployed by Rocket Lab to 151. Congratulations and thank you to our customer, General Atomics, NOAA and SENES, for a successful mission. And congratulations to the whole Rocket Lab team. A huge thank you to you at home as well for tuning into the live stream of Rocket Lab's 31st mission. We're going to end the broadcast here, but remember to follow Rocket Lab's Facebook, Twitter, LinkedIn and Instagram pages for information on our next mission next month. We'll leave you with a song aptly called Electron by Sweet Mix Kids off their recently released album, Stargazing. Thank you again for joining us. My name is Felicity Powell, and this is Rocket Lab Mission Control, signing off.
All IT string disabled.
Stage 1 and Stage 2 are pressed for flight.
Locks load complete. Lock system in recirculation.
Deluge is activated.
T minus 20 seconds and counting.
High flow engine purge is enabled.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
Stage 1 propulsion is nominal.
Plus 31 seconds into the mission, and Electron is airborne after our 26th launch from LC1. We have a great view of that Electron leaving the pad as Electron powers its way to space.